Good evening. Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. The course that we are dealing is Network Analysis and Transmission Lines, and it's a crash course. We are dealing with two-port networks, and the topic for today is characteristic impedance and image transfer constant. So let's see that. Before that, let me tell you about myself. I'm sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services, and also cracked GATE. So let me tell you about the Unacademy Learning App installation procedure. Type Unacademy Learning App in Google Play Store and click on this install when you just get it. And select GATE and Engineering Services, click on plus and click on Get Subscription. You have two types of subscriptions, plus and iconic subscription. You'll get a dedicated mentor for your preparation in iconic subscription, which is very much helpful for the students. And you can use my code YSK10 to get the maximum discount and click on this proceed to pay. Once you do this, you have payment options like debit card, credit card, EMI, UPI, wallets, and net banking. Swarnasri, good evening. Srilata, good evening. Kiran, good evening. Welcome to Unacademy. So, using any of these payment platforms, you can get subscription to Unacademy, the largest online e-learning platform. So, let me tell you about this Evolve for Gate 2022 and Ascend for Gate 2023. So, we have starting new batch Evolve for Gate 2022 and Ascend for Gate 2023. And the first batch has started on 28th December. There are much more batches that are coming, and we have the top educators. So hurry up, get subscription. Iyaz Habib, welcome to Unacademy. So if you just that was about Evolve and Ascend Gate 2022 and Gate 2023, and the topic for today is characteristic impedance and image transfer constant or propagation constant for a symmetrical network. So let's see, the parameters used to measure the performance of a symmetrical network are this characteristic impedance and propagation constant. So let's see characteristic impedance first. Now the characteristic impedance we denote it by Z naught, and the units are ohms. So it is represented by Z naught and the units are ohms. Now if at all, if I consider a network, two port network, let's say this is terminated with some impedance of value Z naught. Say this is terminated with an impedance value of Z naught. And if you try to measure the impedance at the other port, if this appears to be this impedance that you measure is Z naught, it is terminated by some Z naught. Let's consider I2, I1, plus and minus. This is a symmetrical two port network. Right? So if you observe that the impedance measured is Z naught when it is terminated by some impedance Z naught, such an impedance is said to be a characteristic impedance. It is said to be a characteristic impedance. It is also sometimes named as iterative impedance. So this characteristic impedance, it is the impedance when measured at a port is Z naught if it is terminated with the same impedance, or if a network is terminated with an impedance of Z naught, and if the impedance measured at the other port is same as the terminated impedance, then such an impedance is said to be the characteristic impedance. This term is mostly useful in transmission lines. Amshi, good evening. Welcome to Unacademy. So let us consider a T network and a pi network. T network has series arm impedances equal to Z2 and a pi network has shunt arm impedances equal values. Now this is a T network as I told you, and this is a pi network. Srinivas, good evening. So instead of taking these values as resistors, let us consider value as impedance like this. You can also represent it with an impedance. This representation by using a box, this will be Z1 by 2. In general, it is Z1 by 2. So this is Z2. Let us say this is terminated with an impedance of Z0. So let us say there is some impedance that is measured at the input. Balraj, good evening. Soumya, good evening. Welcome to Unacademy. Balraj, welcome to Unacademy. Soumya. So now let us consider this. So this is the T network that we have considered, which is terminated with an impedance of, it is terminated with some impedance of Z0. So from this, what we'll try to do is we'll try to calculate what is Zin. What is this input impedance? You can see Z1 by 2 and Z0 both are in series. So what is the value that you get? It is Z1 by 2 plus Z0. Two impedances are in series. And this combination is in parallel with the Z2. So that is Z2 into Z1 by 2 plus Z0 by Z2 plus Z1 by 2 Z0. And this total combination is in series with Z1 by 2. So I'll write it as Z1 by 2 as Z2 into Z1 by 2 plus Z0 by Z1 by 2 plus Z2 plus Z0. Now just try to simplify this. Zin is equal to Z1 by 2 into, it is Z1, I'm taking this as the LCM, Z2 is Z0 plus Z1 Z2, I'm multiplying this Z2 inside as Z0 Z2 Z0 Z2 put by, just taken the LCM, I've just taken this as one term, taken Z1 by 2 as one term instead of taking 2 as the LCM here. So what you'll get in the denominator, it is Z1 by 2 as Z2 plus Z0. Just try to multiply Z1 by 2 inside, you get Z1 by 4 as Z1 Z2 by 2 as Z0 Z1 by 2 as Z1 Z2 by 2 as Z0 Z2 by Z1 by 2 plus Z2 plus Z0. Right. So let's try to simplify this again. And what do you have in the left hand side? It is still Zin. And when you try to simplify this, separate. What do you get? Zn is equal to Z1 by 4, and this is Z1 by 2 plus Z1 Z2 by 2 plus Z1 Z2 by 2. It is Z1 Z2 plus Z0 Z2 plus Z0 Z1 by 2 by Z1 by 2 plus Z2 Z0. Let's try to multiply this, and we also know that when any network is terminated with an impedance of Z0, and only if the impedance measured at the input is also Z0, then it is a characteristic impedance. So we'll replace this Zin by Zin is equal to Z0. So what can you write? Z0 is equal to, let's try to write this, Z1 by 4 Z1 Z2 plus Z0 Z2 plus Z0 Z1 by 2 by Z1 by 2 plus Z2 plus Z0. Let's try to take this in the next slide and simplify further. Let us consider this Zin is equal to Z naught, and just trying to take this to the next slide and try to simplify that. Let's take this to the next slide. Now what do you get? Just cross multiply that. So Z naught into Z1 by 2 plus Z2 plus Z naught is equal to Z1 by 4 plus Z1 Z2 plus Z naught Z2 plus Z naught Z1 by 2. So just try to multiply Z naught inside. It is Z naught Z1 by 2 plus Z naught Z2 plus Z naught square is equal to Z1 by 4 Z1 Z2 Z naught Z2 Z naught Z1 by 2. Now let's try to cancel these terms. Z naught Z1 by 2 Z naught Z1 by 2 Z naught Z2 Z naught Z2. So what is the value of Z naught square? Impedance Z naught square characteristic impedance is equal to Z1 by 4 plus Z1 Z2, or Z naught is equal to root over Z1 by 4 plus Z1 Z2. This is what you'll get it. Z1 by 4 plus Z1 Z2. So this is, let's look at this. If you look at this, there is Z1 by 2 into Z1 by 2, it is Z1 square. This is what we have done mistake. So it is Z1 square. In the next slide also you'll get Z1 square. So this is Z1 square, Z1 square. So this is Z1 square by 4 plus 1 square by 4 plus Z1 Z2. What is Z0 value? We got Z0 is equal to Z1 square by 4 plus Z1 Z2. This is the value of Z0. So look at this. What have we done? We have just taken this. We have considered this Z in this network wherein these two were in series and the combination was in parallel to this and this was in series to this. So when you are multiplying this Z1 by 2 and Z1 by 2, you'll get Z1 square by 4. What it is. I've just written Z1 by 4. It is Z1 square by 4. Rest of the things, if you just simplify, and you know this Zin is equal to Z0 for it to be a characteristic impedance, so just replaced it, and we have just cross multiplied the things, and then we got it is Z1 square by 4 plus Z1 Z2 root over. Clear? So what do you got? What do you get? Z0 is equal to Z1 square by 4 plus Z1 Z2 root over. Now let us try to take the network, same network, this network, and try to find its open and short circuit parameters. Let's try to just eliminate this as of now and take it to the next slide, and let's find open and short circuit parameters. Now let's say this is an open circuit. We'll find what is ZOC1. Open circuit ZOC1 is equal to, what is that, Z1 by 2 is Z2. Now what is ZOC2? Now if you just take it in the reverse way, if you open circuit this, for that let me write ZSC1. Short circuiting this port and finding the impedance at this port, what will happen? ZSC1, if you just try to find, what is that? Z1 by 2 and Z2 are in parallel. So Z1 by 2 into Z2 by Z1 by 2 plus Z2. Yes, it is in series with this. So it is Z1 by 2. So what is ZSC1 is equal to Z1 by 2. Let's just try to simplify this. This is Z1 Z2 by 2 by Z1 plus 2 Z2 by 2. Just cancel out Z1 by 2 plus Z1 Z2 by Z1 plus 2 Z2. Right? So this is Z1 by 2 plus Z2. Z1 by 2 plus Z2, and this is Z1 by 2 plus Z1 Z2 by Z1 plus 2 Z2. If you just take this expression for Z naught, it is Z1 square by 4 plus Z1 Z2 root over. And if you just multiply this ZOC into ZSC, you'll get the same value of Z naught square, which is Z1 square by 4 plus Z1 Z2. You can write Z naught square is equal to ZOC into ZSC, or Z naught is equal to root over ZOC into ZSC. Right? This is the value of ZOC that we got. Try to multiply them ZOC into ZSC. What is that? Z1 by 2 plus Z2 into Z1 by 2 plus Z1 Z2 by Z1 plus 2 Z2. Just try to multiply this Z1 by 2 into Z1 by 2, it is Z1 square by 4 plus, just try to multiply this Z1 square Z2 by 2Z1 plus 4Z2 plus Z1 Z2 by 2 plus, you can also write it as plus Z1 Z2 square by Z1 plus 2Z2. Just try to simplify this, you'll get Z1 square by 4 plus Z1 Z2. Right, so this is how you'll just do it. You just try to take this open and short circuit. If you just try to simplify them, get these values, get Z naught is equal to root over, Z naught is equal to the root of Z1 square by Z1 square by 4 plus Z1 Z2. Or if you just try to write this in terms of ABCD parameters also, you can just find this, and this is how you'll determine the characteristic impedance. This is characteristic impedance Z naught. The units are ohms. Okay. Now let's try to consider image transfer constant. For a symmetrical network, it is also called as propagation constant. So this is generally denoted by theta or phi. So because this image and iterative impedance cannot completely describe the symmetrical network, we use this image transfer constant. You can consider image transfer constant is theta or theta I, and you can write it as e power theta I is equal to under root of e1 I1 by e2 I2. For this, you just need to need to have a network which is supplied by some source and which is terminated by some impedance. The value here is considered to be E1. The current is I1. This current is I2. The voltage at this point is E2. And this is some given generated voltage or given supply voltage, and this is a symmetrical network, symmetrical two-port network. This is symmetrical port network. So let this impedance be Zi2. So you just have to replace this E1 is equal to, what is E1 is equal to I1 into, if I say the impedance here is Zi1, so it is Zi1, and E2 is equal to I2 into Zi2, and you just have to simplify this, substitute these values, so you'll get e power theta I is equal to root over I1 square Zi1 by I2 square Zi2. You can also write it as I1 by I2 root over Zi1 by Zi2. You just need to find this Zi1 and Zi2 image impedances, Zi1 and Zi2, and just need to simplify this and substitute in this. Finally, because this is a crash course, we may not be able to derive all things, so you can write it as finally get tan h theta is equal to under root of ZSC2 by ZOC2. This is what finally you'll get it. So tan theta is equal to, or tan phi is equal to, under root of ZSC2 by ZOC2. Short circuit impedance of the second measured across second, and open circuit impedance measured across the second port. Or you can also write tan phi as tan phi is equal to, and tan and h phi is equal to under root of EC by AD in terms of ABCD parameters. This is the image transfer constant. It's called as the image transfer constant. In symmetrical networks, image transfer constant is also called as the propagation constant. For a symmetrical network, this is also named as the propagation constant. Let's try to solve one problem based on this concept. So let us consider one question you have. Let us consider you have one question, and the question is, I'm taking this from one of the questions. It is given as a resistor. There are two resistors given like this. The T network, which is L section purely. So this value is given as J 300 ohms, and this is given as minus J 400 ohms. So instead of writing these as resistors, just take them as impedances because they're J representations. So just take it as impedance. Yeah. So what is the question is, determine the image impedance and image transfer constant for an L section shown. Determine image impedance and image transfer constant for the L section network shown. So what is that you need to do? You need to determine the image impedance. So what is the image impedance? It is Zi1 and Zi2. So we already know Zi1 is equal to under root of ZOC1 into ZSC1, and Zi2 is equal to under root of ZOC2 into ZSC2. So this is just the multiplication of open circuit and short circuit impedances, which is the image impedance. So first write what is ZOC1 and ZSC1, and then write ZOC2 and ZSC2. I'll just give you a few minutes to do this. Just tell me what are the values. ZOC1, ZOC1 is nothing but it is open circuiting this. I'll just try to draw this clearly one by one. Let's do it one by one. So to find ZOC1, what you have to do, you just need to open circuit second port. Just need to open circuit the second port. This is open circuit, and you need to measure the impedance here, that is ZOC1. So this is J 300 ohms and this is minus J 400 ohms. When you measure impedance at this point, it is ZOC1 is equal to J 300 minus J 400. So ZOC1 is equal to minus J 100 ohms. Is minus J 100 ohms. Similarly, let's try to find, I have an impedance here, another impedance here, and this is given like this. What is ZSC1? That means if you have to find this, you need to short circuit this. This is J 300 ohms, this is minus J 400 ohms. You short circuit this will not come into picture, or it is neglected. So ZSC1, it will become dummy. So J 300 ohms. Similarly, let's try to find ZOC2. How do you find ZOC2? So let us consider this is 1 dash port, right? So that is the reason ZOC1. This is 2 dash. So you have another impedance. So you are finding impedance across these terminals. ZOC2. Now when it is ZOC2, this must be open circuit. So J 300 ohms is minus J 400 ohms. If you try to find ZOC2, it is minus J 400 ohms. Similarly, let's try to find ZSC2. What is ZSC2? Just try to take this 1 dash. We are measuring this 2 dash. ZSC2 must be found here. This is Z minus J3, sorry, plus J, and this is minus J 400 ohms. And ZSC in the sense, you need to short circuit this. When you short circuit this, these two will become parallel. So ZSC2 is equal to J300 into minus J400 by minus J100. So JJ will get minus 1, and this will give you ZSC2 will give you J into J square minus 1 minus, already you have a minus, so that will become plus. This is 4 3s are 12 by minus J100. If you just simplify this, you'll get it as J 1200 ohms. You can cancel these two. You can just take this J to the numerator, you'll get this value of Z. So let's try to write all these values at one place. ZOC1, ZSC1, ZOC2 and ZSC2. Now just write these values. What are the values that we got? ZOC1 minus J100 minus J100 ohms, and ZSC1 J300, ZSC1 J300 ohms. And what is this ZOC2 minus J400 minus J400 ohms, and this is J 1200 ohms. Once you are done with this, you need to calculate ZI1, that is under root of ZOC1 into ZSC1. This is root over minus J100 ohms into J300 ohms. ZI1 you'll get it as 173.21 ohms. Really, what is ZI2? It is root over ZOC2 into ZSC2, which will give you root over minus J400 into J1200. This will give you the value as 92.8 ohms. So this is ZI1 and ZI2. What is the other thing that we are asked to find? We are also asked to find wage transfer constant. So let's try to see that. Next, this is the L section that is given to us. So what is tan H phi is equal to root over ZSC2 by ZOC2. This is what we have done. So tan H phi is equal to under root, what is ZOC2? ZSC2 and ZOC2. ZSC2. ZSC2 is J1200 by ZOC2 minus J400 minus J400. So this is under root of, if you just take this J to the numerator, it is J square into, and cancel these two with these 3 brackets. It is J square into H phi is equal to, you'll get J into 1.732. In order to calculate this phi again, you can also split this. Still, you can write tan theta is equal to, or tan h theta is equal to e power theta minus e power minus theta by e power theta plus e power minus theta. So you can still write it as tan h phi is equal to e power phi minus e power minus phi by e power phi plus e power plus phi is equal to j 1.732. This can take the component of dividend of this. So it is e power phi minus e power minus phi by e power phi plus e power minus phi is equal to 1.732 j. I just take the component of dividend of this. You get e power phi minus e power minus phi plus e power phi minus e power minus phi by power phi plus e power minus phi plus e power phi plus e power minus phi is equal to plus 1.732j minus 1 plus j 1.732j. If you just simplify this, you'll get e power phi is equal to 1 at an angle 1.047 minus 1.047. Still, you can write it as 2 phi is equal to ln of 1 at an angle minus 1.04, or you can take log on both sides. If you just try to simplify this, you'll get 2 phi is equal to j 1.0472 plus 2 pi n. So just substitute the values of n is equal to 0, 1 and so on. Likewise, if you just do that, you will get 2 phi is equal to minus j 1.0472 for n is equal to 0, and 2 phi is equal to j 5.236 for n is equal to 1, and so therefore phi is equal to, you can write it as j 2.618 from this, which gives you what is phi. Actually phi is equal to j into beta. So with this beta value of 2.618 radians, this is gamma. Actually gamma is equal to alpha plus j beta, right? So alpha is attenuation that you have not considered enough. You can write this beta value as 2.168 radians. So this is how you will determine image impedance and image transfer constant for a given question. So once again, let's see what we have done. We were given a question like this. This is a L section work that is given to us. We have considered Zi1 is equal to root ZOC into ZSC1 and Zi2 is equal to root ZOC into ZSC2, and we try to find ZOC1, ZOC2, ZSC1 and ZSC2, right? When you do that, you have got values of ZOC1, ZSC1, ZOC2 and ZSC2. Then you can find Zi1 and Zi2. Then you have written the expression for this J 300 ohms and minus J 400 ohms, 2 dash and 1 dash. So from this you got the value of phi actually, or it is tan h gamma, is alpha plus j beta. You need to determine that, or you can also stop it this way, where tan h phi is equal to this. Because this is imaginary, we try to write it in this fashion, right? So we have got this session today. We have seen what is characteristic impedance and its expression z0 is equal to under root of z1 square by 4 plus z1 z2 ohms, and image transfer constant as an h phi is equal to root over e1 I1 by e2 I2, or you can also write it as tan h phi is equal to root c by ad. So these are the two things that we have discussed for today, and We have also solved one problem based on them. How do you find characteristic impedance and the image transfer constant? Kumar, good evening. So this is what we have discussed today, the characteristic impedance, image transfer constant, the problem based on them, this phi, or it is also theta I or theta, or it is gamma for a symmetrical network, propagation constant. So we have found characteristic impedance, image transfer constant, and a problem based on them. So once again, as I always tell you, we have India's number one study channels: Theatrics Gate, Unacademy Gates E, Unacademy Gates E, Unacademy Gate Telugu, Unacademy SSCJE, Unacademy Computer Science, Unacademy Gate Questions, Unacademy Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala, and Unacademy Semester Exams. So please do like this video, share this video, use my referral code ISK10 to get the maximum discount of 10% on your next Unacademy subscription. Subscribe to Unacademy and click on this bell icon to get more notification of my classes. And once again, I'd like to tell you about starting a new batch, Evolve for Gate 2022 and Ascend for Gate 2023. A batch has already started and there are many more batches where the top educators of Unacademy take the classes. So hurry up, get subscription to Unacademy right now. So thank you all. Thank you for joining me this session today on network analysis and transmission line two-port networks, characteristic impedance and image transfer constant. Thank you.